In this video, we're going to use what we know about trig ratios, and we're going to use them to set up equations and solve equations to find missing parts of right triangles. In order to do that, we need to do a couple things. First, we need to identify the angle in your triangle that you know. We're going to identify an angle you know the size of. And then after you did that, from its perspective, we're going to identify one side that we know and a side that we're looking for. One side we know, and the side you're looking for. What I mean by identify is, like we did above, we're going to identify as and label the names of these of the sides. So, for instance, in this first example, this angle I know is 41 degrees. So, from this 41 degree angle perspective, this side that's 17 is a leg that's across from it. So we'll call this the opposite leg. From this 41 degrees perspective, the leg that's touching it is side C. So that must be the adjacent leg. And I know this is the adjacent leg because I definitely know where the hypotenuse is. The hypotenuse is across from the right angle. So this is the adjacent leg. Once we know that, in this case, in this 41 degrees case, I know that this side that I know the length of, which is 17, is the opposite side. And I'm going to choose one of the other sides I'm looking for. How about we'll start with this side C that's adjacent to it. Knowing this, I'm going to write a trig ratio. So how do I do that? Well, I'm going to decide what trig function goes along with these with the side I know and the side I'm looking for. It's helpful to have something memorized so you know which one to go, sine, cosine, or tangent. And there's a really classic and common mnemonic or way to remember this. And the classic way is called SOHCAHTOA. It's a fun word to say. It's when you slam these letters all together. Maybe a better way to write this would be something like this. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. SOHCAHTOA. So in my picture here, I know from this 41 degrees angle, I know 17 is the opposite side, C is the adjacent side. The trig function that uses opposite and adjacent, O and A, is tangent. So I think the tangent of this 41 degree angle is equal to the opposite leg over the adjacent leg. So I would write my equation like this. Tangent of 41 degrees equals 17 divided by C. Or better yet, tangent of 41 degrees over 1 equals 17 over C. This to me is a proportion. The thing I'm looking for is this C. This trig function with this angle plugged in, this is just a decimal this is just a decimal of some sort. It's a whole number, a decimal, but it's a number. And your calculator is really good at calculating what these are. In the case of tangent of 41 degrees, it turns out tangent of 41 degrees, your calculator can find. Sine, cosine, and tangent are trig functions. So if you're using Inspire, they're in this button that says trig. And when you click on it, it brings up a menu, and you can see sine, all these trig functions, including other ones too that we'll eventually talk about later. So we want to do, and to show you what this value is, I'll do tangent of 41 degrees. I'm going to make sure it's measuring in degrees. There are multiple ways to measure angles. I'm going to force this to make sure it's in degrees. And the degree symbol is right underneath a pi. So I'm going to click on the pi button on my Inspire, and I'm going to go down and hit the degree symbol. It's all tangent of 41 degrees. And if you hit enter, it tells you that the tangent of 41 degrees is, well, about 0.869287, blah, blah, blah. It's a decimal number. So I can solve this equation. This proportion we can solve just like every other proportion by cross multiplying. So I could take this c and this tangent and this decimal, whatever tangent 41 is, multiply together. Take the 17 and the 1 that's under this tangent, because I can put a 1 under anything to make it a fraction, and get that c times whatever this decimal of tangent of 41 degrees is equal to 17. Or I can get c by itself by dividing by whatever this decimal is. Note that I'm not writing the decimal here. I'm writing in this symbol of what the decimal would be at tangent 41, because I can type what I'm going to do is, rather than worry about this decimal typing it over and over again, I'm just going to type 17 divided by tangent of 41 degrees in my calculator. So I'll do that to find what c is. We'll do control divide to get a fraction, 17 on top, and then trig tangent of 41, and then the degree symbol is underneath of pi. Hit enter, and tangent 17 divided by tangent 41 is 19.5563. In your directions, it'll tell you what to round to. Usually if we don't tell you the directions, you should round to 3 decimal places, but often there'll be directions for what to do in this case. I don't have them here, so I'm going to round to 3 decimal places. 19.556. Let's try something similar to try to find what d is. So the angle I still know is 41. I know that the side that I know is 17. That's across from 41 degrees. That's the opposite. And now I'm looking for the hypotenuse. So the trig function that uses opposite and hypotenuse, O and H, is the SO of SOHCAHTOA, or sine. So this time I think that the sine of 41 degrees is equal to 17 over d. And again, I can make this a proportion by putting the sine over 1. Sine 41 is just a decimal that your calculator will figure out. So let's get d by itself, and then I'll type all this stuff in my calculator. D cross multiply should get d times the sine of 41 degrees is equal to 17 times 1, which is just 17, divided by sine. And d is 17 divided by the sine of 41 degrees. So d is fraction 17 trig sine 41 degrees, which is about 25.912. Let's try solving this problem. Let's see. I know that I know this angle is 47. The side opposite of 47 is y. The hypotenuse is 12. So that means that x must be the adjacent, again, from 47 degrees perspective. So let's see. Maybe I find x first. From this 47 degrees, I'm looking for x, and the side I know is the hypotenuse. So the function that uses adjacent and hypotenuse is a and h. That's the ka in SOHCAHTOA. That's cosine. So I know that the cosine of 47 is equal to the adjacent over the hypotenuse, which in this case is 12. Or I can put this over 1. I can do some cross multiplying x by itself. This is nice because when I multiply 1 and x, that's just x. When I multiply 12 and cosine of 47, this 47 is an input to this function. So I'm not going to multiply the 12 and the 47 together. I'm going to multiply 12 and whatever decimal I get when I type in 47, when I find the cosine of 47. So I'm going to write it like this: 12 times cosine of 47 degrees. I'll type this into my calculator. I'm getting a little annoyed, and I don't want to keep having to type this degree symbol every time. You can avoid having to type this degree symbol if you make sure your calculator's settings is in degrees, measuring angles in degrees, or in degree mode. I know my calculator right now is not, because I see the 3 letters RAD at the top. Right now it's measuring angles in radians, unless I tell it to measure in degrees with a degree symbol. I can just set the default to be in degrees, so I don't have to keep typing this degree symbol. By doing this on your Inspire, you're going to hit Doc Settings, which is option 7, in Document Settings. In the Document Settings, I'm going to change the angle from radian to degree. Note there's a third way to measure angles called gradients, but we don't really care. What we care about is angles are in degrees. I'll come down. If your calculator says make default, you can make it the default, or just hit OK. And now I can do all these calculations and not have to hit the degree button to make it work. So let's figure out what 12. Let's figure out what 12 times the cosine of 47 degrees is. And since I'm in degree mode, I don't need to type the degree symbol. Hit enter. That's about 8.18398, or how about to 3 decimal places, since it doesn't tell me where to round. How about 8.184? Do the same thing. Let's find y. Y from this 47 degrees angle is opposite, and I know the hypotenuse is h, so O and h is SO of SOHCAHTOA, or sine. So I know the sine of 47 degrees is opposite over hypotenuse. Cross multiply, you get y is equal to 12 times the sine of 47 degrees, which is about 12 times trig sine of 47 degrees, which is 8.776. I'll do a few more problems this time instead of using, but for these instead of using an Inspire, in case you don't have one at home or haven't downloaded the free Inspire student software that you have access to. You can find that software on Canvas in the resources module that we've added. You can download and get access to a free computer version of Inspire here. And I highly recommend you check that out. But if you don't, I'll show you how to use just the standard scientific calculator that you can get by just typing online calculator into Google to solve these problems, because you can do that as well. Let's set up these problems, and we'll use the free Google calculator here to finish these problems. Let's find the value of x round to the nearest tenth. In this problem, I want to find x. The angle I know is 25. That means this 12 is opposite. And this x is the side that's across from the right angle is the hypotenuse, meaning that x is the adjacent side. So from this 25 degree angles perspective, we know the opposite leg, and we're looking for the adjacent leg. O and A is TOA in SOHCAHTOA, T-O-A. So I think this means that we're going to use the tangent of this 25 degree angle. And this equals opposite over adjacent. Better yet, we'll put this under a 1. Cross multiply. Get x times whatever the tangent of 25 degrees is. That should equal 12 times 1, which is 12. Divide by whatever this decimal is. Tangent of 25 degrees. and therefore x is whatever 12 divided by the tangent of 25 degrees is. I can use my Google calculator to figure this out. I'll do 12 divided by the tangent, there's the tangent button, of 25. Before I hit enter, I need to make sure my calculator is in degree mode, and note that here are the two common ways to measure angles, radians and degrees. Make sure that degree is the one that's highlighted, otherwise you'll get a very wrong answer. So I want degree highlighted here. Degree is now highlighted, and I'll hit enter, which means that I think that the value of x should be to the nearest tenth now. That's the first decimal place. Should be, I think, 25.7. X is the opposite side. 13 is the adjacent side. Again, opposite and adjacent, that's the OA, that's the TOA of SOHCAHTOA. So I think tangent of 56 degrees is equal to opposite, which is in this case x, over adjacent leg, which is 13. Put a 1 under the trig function, cross multiply. This is a nice one because since the variable's on top, we'll just get x. This is equal to whatever 13 times the tangent of 56 degrees is. Now my calculator here, I can do 13 times the tangent of 56 degrees. I'm still in degree mode, which is good, and enter. So x is to the nearest tenth, you think 19.3. Couple more. From the 61 degrees perspective, 22 is opposite, x is adjacent, tangent again. So I think the tangent of 61 degrees is equal to opposite over adjacent. Cross multiply, x tangents of 61 degrees is equal to 12 times 1. Divide by whatever the tangent of 61 degrees is. And I get x is equal to this fraction, 12 over 61, which is 12 divided by the tangent of 61 degrees. I'm still in degree mode. It's good. That tells me that x is about to the nearest tenth, which should be 6 point, I think, 7. Oh, it should not be 6.7 because for some reason I decided to miscopy this down wrong. It's not 12, it's 22. That's an easy mistake to make. It's not a very smart mistake to make, but it's a mistake you can make. How about 22? Well, we do this correctly. How about 22 divided by the tangent of 61? Get the right answer. How about this a lot better? How about 12.2? That's good. Okay, lastly, 70 degrees we know. Opposite leg, adjacent leg, tangent one more time. Tangent of 70 degrees is equal to the opposite over adjacent. Cross multiply, 1h is equal to 40 times the tangent of 70 degrees. And according to my graphing calculator, 40 times the tangent of 70 degrees is 109.899, or to the nearest tenth, 109.9 inches.